Okay. Welcome to the AMATIC 2016 webinar series. This is using data visualizations to improve understanding about the labor market and economy by Jay Meisenheimer. This presentation is sponsored by the Joint Committee of AMATIC and the American Statistical Association. Jay Meisenheimer is the chief of the Division of New Media at the U.S. Bureau of Labor and Statistics. From now on, I'm going to call it BLS. The division oversees all content on the BLS website and manages the BLS social media. New media staff members spend much of their time developing interesting and informative graphics and helping their colleagues in other BLS offices do the same. Jay spent the first 22 years of his career working as an economist in several BLS statistical programs. He also spent a year on the staff of the Department of Labor of Chief Economist. During Jay's 4 years in new media, he's tried to apply the lessons he learned from his prior jobs about communicating complex statistics clearly. He realizes there is always more to learn. Jay's wife and his 4 children agree that he has much to learn. My name is Julie Gunkelman. I'm the Professional Development Coordinator for AMATIC, and I'm going to be your host today. The links that I'm going to have up here are for AMATIC, American Mathematical Association of Tier Colleges, core value, building expertise and exhibiting leadership in the teaching and learning of mathematics, enhancing personal growth, improving teaching methods and effectiveness as a personality-initiated lifelong responsibility. For more information, please see amatic.org. Please note that the views expressed by the presenter are not necessarily the views of AMATIC. Commercial products mentioned by the presenters are not endorsed by AMATIC. WebAssign is the proud to support the AMATIC webinar series again this year. And right now I'm going to turn it over to Jay.
Good afternoon, everyone. Can you all hear me? Everybody? Good. Okay, good. I said good afternoon. I realized some of you might be in a different time zone, and it might still be good morning. My name is Jay Meisenheimer. If you happen to have heard me give a similar webinar to this back in October on World Statistics Day, I apologize if I tell some of the same jokes, but you know, I go with what works. But do feel free to use the laughter and applause buttons. I thrive on the feedback. Let me start off a little bit by telling you about what the Bureau of Labor Statistics does, in case you don't know. We're the folks who put out, I guess, the most famous or infamous, depending on your perspective, thing that we put out each month. We put out the monthly unemployment rate. We also publish statistics on employment, prices, productivity, safety and health statistics such as workplace injuries and illnesses and fatalities. We have statistics on how people spend their time outside of work, leisure time, and other household activities, traveling, those types of things. We have, in short, we have lots of statistics on lots of different topics. And I'm not going to cover probably all of them today, but I hope to go over at least a good many of them to give you some examples of how we have presented data. So, can I advance one frame? How do I do that?
Remember, it's the buttons on the bottom. You might have to click on the screen to get it to go. But you should be able to advance them. It's not doing it?
Oh, wait. I got it. Okay.
Okay, super.
Yeah, Julie, it only takes me, 6 or 7 times to go through something to finally figure out how it all works. Sorry about that. So I'm going to talk about data visualizations. What do I mean by data visualizations? Basically, we're talking about charts and maps. It's kind of a fancy term, one of those fancy $5 terms that I hear people used a lot. But throughout my talk, I might occasionally use the term data visualization, but mostly we're just talking about charts and maps and graphs. So why do we use graphics? BLS has been around a long time. We were established in 1884, and over that century plus 132 years almost, we've published lots and lots of things over that time, and we were always really good at putting sort of data of record in long, voluminous tables and analytical text and technical documents. it's really only been in about the last decade or so that we've used graphics more widely. I've actually gone back and looked at some of our old publications. We did have graphics over the years, but they're very much very primitive compared with what we do today. Why do we use them? Well, the simplest answer is they're useful for presenting complex data in a more simple manner. But I think graphics work well certainly with general audiences, but also with expert audiences as well. I'm really good at analyzing data. I'm sure that many, probably all of you, are good at analyzing data as well. Sometimes there are things that you can just really understand a whole lot better with a picture than by just looking at regression parameters or descriptive statistics or things like that. A picture really helps really helps us understand our analyses a lot better, I think. I like to tell people around BLS who, one of the things that the BLS is famous for is we like to tell you, people here know a lot about the data and they don't mind telling you a lot about the data. But, not all of our data users have the luxury of time, of really spending a lot of time on something. So a good graphic can help us communicate a lot more quickly, a lot more effectively than we can with more technical long-form documents. And lastly, I really think that good graphics help to stimulate curiosity. As Julie mentioned, one of the things I do here, I oversee our social media accounts, Twitter, mostly Twitter, and when we tweet new publications, we always try to include a good graphic in the tweet. We find that it tends to help our readers engage more. They see an interesting graphic. It's like, oh, I'm going to click on that. I want to read more. To use kind of a crass term that we try not to use around here, it's kind of clickbait. But as I say, I prefer calling it stimulating curiosity. One of the things that we have done during my time in my current job, which has been about the last 4 years, we used a lot more interactive graphics. And I'll explain what I mean by that, or I'll show you actually what I mean by that in just a moment. We've all gotten used to static images. Basically, you have a graph of some sort, a picture. Hopefully, you can discern some sort of interesting story from the graphic. If it's well designed, but interactive graphics enable us to do more. So what you see on the image on the screen here is just a simple interactive graphic. It has some pros and cons. One of the things that I think is a little bit difficult to understand about it is that it has 1, 2, 3, I think 8, maybe 9 lines on it. That's probably beyond the capacity of the human mind to really grasp in a line chart. In fact, there's research that supports the idea that if you have more than 4 or 5 lines on a line chart, even the smartest among us, and I'm not claiming certainly to be one of the smartest among us, it's difficult for our brains to really process that many data series all at once. So, if I can jump to the interactive version of this same chart. This is a chart showing, this is a publication we have called the Economics Daily, or TED for short. And so this is a kind of a short story. As I said, we put one out every day. This one's on long-term price trends for computers, TVs, and related items. So let me scroll and enable you to see the graphic itself. Hopefully everyone can see that. If you need me to, I can make it a little bit bigger.
Hey, Jay, I'm
Yeah.
sorry to interrupt you. Did you want me to switch to your screen?
Yes. Sorry about that.
Okay. That's okay. I wasn't sure.
Okay, there we go. Okay, so what you should, I'll minimize that. So what you should see is an interactive version of that static image that we were looking at just a moment ago. This shows price trends, consumer price trends for TVs, computers, related types of things, photographic equipment. Now, what you see right here looks a lot like that static image that we were looking at a moment ago. Actually, this image is maybe a little bit too big for my screen, so I'm going to make it just a little bit smaller. So the interactive version of this does some things for us. One of the things is that we have these legends. So if I hover over a legend item, I can show what the price trends have been for cable and satellite TV services. You'll notice that it's going up, up, up. Looking at the other end of the spectrum, let's look at the prices for personal computers and related equipment. Down, down, down. Computers have just gotten better, more powerful over time, and at the same time they've gotten less expensive. Similar for televisions. When I hover over these items in the legend, I can highlight the series that I want to see. If I want to, I can just turn off series that I don't want to see. I don't really care that much about photographic equipment and supplies, so I'm going to click on that and turn it off. I don't care about audio equipment. For now, I don't care about computer software and accessories. I'm going to turn these other things off. So you can see, if I want to focus on, say, just these three, cable and satellite TV, televisions, and personal computers, I have the ability to turn those series on or off. Another thing that interactivity enables us to do is if I run my mouse across the lines, I can see the actual index numbers. All these prices are expressed as index numbers starting with 1997 equaling 100. So I can see the individual data points. One other thing I can do, I want to note this, all of the graphics that we publish, we have a table behind it. And I will click on this little tab here where it says chart data. So these are all the data that feed into the chart that we're looking at. We do this for a couple of reasons. One is that we do it to comply with the letter and the spirit of the federal law that requires us to make our information accessible to people with disabilities, in this case particularly people with visual impairments. An electronic reader for someone with a visual impairment can read this table very well and be able to translate the information in the chart. And that's why we provide it. But also, frankly, a lot of people who come to the BLS website, who get information from the BLS website, they're kind of like I am. They're really into the data. They're nerds, if you will. And so this provides provides easy access to enable them to get to the underlying data if they want to do some more with the data, manipulate it in some way that we haven't done here in the graphic. So that's an example of how we do interactive graphics, and I'll talk more about that in a minute. I'll give you a few more examples. So, Julie, can we go back to my presentation just for a minute? There we go. So, where do we use graphics at BLS? We have lots of different publications. I just mentioned one of them. It's called the Economics Daily, or TED for short. Another publication that we'll look at some examples a little bit later. It's called Spotlight on Statistics. It's actually similar to TED. It's basically telling a story through graphics, but it's really in a slideshow format. It's really a series of graphics. Each day's edition of the Economics Daily includes one, sometimes two graphics. Spotlight on Statistics is usually telling a longer story, sometimes with 8, 10, 12, maybe even more graphics than that. We have some other publications. I won't spend a whole lot of time talking about them. Beyond the Numbers is more there's a lot more text and beyond the numbers. We do use graphics in them, though. Monthly Labor Review is sort of like a scholarly journal that we have. In fact, we're celebrating this year the 100th anniversary of the Monthly Labor Review, and we try to make it readable, of course, to a broad audience, but it does tend to be more general, more technical, somewhat like an academic journal, at least in the eyes of some readers. And we have lots of other publications that I'll talk about in a little bit, news releases and blogs and so forth. But today I'm mostly going to focus on the Economics Daily and some examples from Spotlight on Statistics. So I'm going to go through very quickly, or fairly quickly, a series of other graphics. So I'm going to go back to my website. And can you all see that? I'm going to ask Julie
you have to hit share my screen again from
Yep, sorry about that.
It's okay. It's okay.
There we go.
We're going to get it awesome by the end.
Yes. We'll be perfect at it just in time to end, I guess. So here's another simple line chart. This is one you can show your students. This is the lesson on stay in school, kids. Look at the unemployment rates for people with less than a high school diploma or high school graduates without college versus bachelor's degrees. Again, the interactivity enables us to, I think, see the data a little more clearly. With this particular graphic, there's only 4 lines, and they don't overlap at all. They don't cross each other at all. So interactivity for this particular type of graphic isn't that essential, but I do think it is a nice feature. Let me move on to the next one. I want to show you several other types of graphics. So this is what we call a column chart, or actually a stacked column chart. So this is showing, let me blow this up a little bit, make it a little bit bigger. This is showing changes over time in different components of compensation. So we have wages and salaries, and we have different types of benefits. Retirement and savings benefits, paid leave benefits, insurance benefits. That includes things like health insurance, life insurance. And what are called legally required benefits. Those are things like Social Security, or the amount your employer pays in towards Social Security and unemployment compensation and things like that. So again, if we hover over the particular section of a graphic, we actually see the dollar amounts. For wages and salaries, we can go down here and look at the dollar. These are all in terms of per hour worked. So legally required benefits cost private sector employers $2.50 per hour worked. Insurance benefits, $2.57. Wages and salaries, a little under $22. If I want to, I can turn any of these off and focus on one particular type of benefit. So in this case, I have a graphic just of insurance benefits, just by clicking the items on and off in the graphic. As with one of the earlier graphics we looked at, if I hover over the items in the legend, I can highlight the particular categories. Moving on to our next one. This is basically a scatter plot. It's showing, let's make this a little bit bigger. As I get older, I appreciate more the need for making print big. This is a graphic that shows the number of job openings in broad industry groups. And this one also happens to have a 45-degree line to help kind of guide the reader's eye. When you see the items above the 45-degree line, so this is comparing November 2015 on the y-axis to November 2014 on the x-axis. So anything above that 45-degree line, it basically means that there are more job openings in the most recent period than in the previous period. So we have things like healthcare and social assistance, more job openings available in November of 2015 than a year earlier. Down here, some of these smaller industries like the information industry, fewer job openings in 2015 than in 2014. We have the little mouse overs that actually show these numbers for both periods. And again, with the legend, as I hover over these, I can click on them to turn something on or off, or just highlight it to help show up. Moving on to the next one. So here, this is a bubble chart. Make this one a little bit bigger. So bubble charts are useful. We use bubble charts to show really 3 dimensions of data. Most graphics show data really in 2 dimensions. Those dimensions might be, a particular measure such as an unemployment rate and time. So we might have a percentage on the y-axis and just basically a timeline on the x-axis, or different categories of things. Here, for this graphic, it's a bubble chart. It's showing for different types of occupations the median annual wage on the vertical axis, the y-axis, and the projected percentage employment change on the horizontal axis. And then the bubble size itself indicates how big the industry is. So again, we have a legend above the graphic where we can turn items on or off or highlight them. We can hover over the items right there to see what this particular industry is. So this big purple one here, at least it looks purple to me, I don't know if it looks purple to you or not, is what we call healthcare practitioners and technical occupations. That's projected to grow about 16% over the 2014 to 2024 period. Median annual wage about a little less than $62,000, and the projected employment change also, that's a lot of jobs. About a little over 1.3 million. Bubble charts are one of the charts that I think we all learn to read when we're in school, when we're at a very young age. We learn about kind of numeracy, learning about different math functions, just at a very young age, recognizing numbers, learning how to do basic math functions. And as we move on in our academic careers, we hopefully learn a little bit more about math. In my memory, I don't really remember having a class where we focused a whole lot about I guess what I've heard called graphicacy, the ability to understand graphics. And bubble charts are, I think, one of those things where, the first time I ever saw a bubble chart years ago, didn't like it much. It seemed like there was a lot going on. And it didn't seem very intuitive, but the more I studied them, the more I've come to appreciate them. I don't know how you all feel about bubble charts, but this is actually one of my favorite chart types. As I said, it's useful for presenting data in 3 dimensions, which is something that most graphic types really don't enable us to do. So you can really pack a lot of information into a fairly small space. So I think, Julie, I'm ready to go back to the presentation for a few slides. So, one of the things that people find interesting with a lot of our data, you've all heard the expression that all politics is local. Well, that's really true for economics as well. Much of economics is local. People care about where they live, where they work, and economic conditions locally. We do care about certainly national economic conditions and certainly international economic conditions. But people are certainly very interested in where they work and where they live. And so we have a lot of data at BLS on geography. And, the first thing that we think of when we think of geography is, well, we're going to have some sort of map. Sure. But maps are not the only way that we can present geography. We've done it in some charts, and I'll give you. I'm going to show you a few of those examples. So let me kind of get ahead of myself. So yeah, for the next several slides, we'll look at first at some charts, and then at some graphics, and then we'll get into something called animated graphics, which are really, really cool. So let the anticipation build on this. All right, so let's go back to the website again. There we go. Julie, I think we're getting this finally. I think we finally understand what we're doing here. So we're about halfway through, which is a good place to be. So this is a graphic. Let me minimize that thing. So this is a graphic. I'll try to expand this a little bit, blow it up a little bit. So this is just a bar chart showing state by state percent changes in non-farm employment. One of the things that maybe is a little bit too much for this graphic is it's really long. It's really tall. Not great for certain types of screens because it's a really tall graphic. But you can kind of get the picture of it here as I scroll down. So this is showing just overall. We published this almost 2 years ago. So this was showing percent changes in non-farm employment by state. As with some of the other charts we've looked at, we can see the percent changes with the mouse over. Alabama grew 0.8%. Alaska actually had a little bit of an employment decline during that period. But notice this drop-down menu right above the graphic. So the default view is showing total non-farm employment, but we can choose other categories. So let's jump down and show manufacturing, so we can get a different picture for different types of industries. Again, this is just one example of a cool way, I think, to present geographic data in a graphical form rather than a map form. Let's move on to another example. Still different kind of graphic. Again, let's blow this up a little bit. These are showing unemployment rates for states and for metropolitan areas. And so the big red dots, these big red tomatoes you see, those are the state unemployment rates. And along the timeline, or along the horizontal axis, I should say, the little blue dots are showing the unemployment rates for metropolitan areas within the state. So again, this is a bit taller of a graphic than I would like, given the particular screen dimensions I have right here. What the horizontal axis is showing is the unemployment rate, in percentage terms. So, so here we have for California, the big red dot, 6.7%. This was as of December 2014, so a little over a year ago. Blue dots are all the metro areas within California: San Francisco, San Jose. These were all below the state average. And actually, this vertical line you see right here, this is the U.S. rate, which at that time was a little over 5%. But we can see some of the metro areas within California that were below the California rate and below the U.S. rate. Way out here, this is El Centro, California. Nearly every month it has the highest unemployment rate, or among the top 2 or 3 highest unemployment rates in the entire country. Usually number 1 is Yuma, Arizona, right up here. So you can see that even though we look at, we see a national average unemployment rate of a little over 5%, across different metro areas. Oh, there, right there it is, 5.4%. I didn't notice that. There's considerable geographic dispersion around that overall national average. Now let's move on to some maps. So this is a pretty recent one. I'll blow this one up, make it a little bit bigger. These are union membership rates, state by state. The states in the darker blue, those have the higher union membership rates, so not surprisingly, places like Illinois and Michigan. The state with the highest union membership rate in the United States is New York. But others, California, fairly high, Nevada, Oregon, Washington. So one of the things that we can do with the legend on this map is if I hover over this top category, I can really, it helps to highlight, it really helps to light up the states with the high union membership rates. Or the states with low union membership rates, or any of those in between. Another thing that this graphic has, there's a little, there's actually a column chart right underneath it, so you can see kind of how states stack up. And at the same time, so I'm right here, I'm hovering over South Carolina, which has the lowest union membership rate in the U.S. And at the same time, if you can see that on your screen, as I hover over the little column on the chart for South Carolina, at the same time, South Carolina is also lighting up on the map. So that union membership rate for South Carolina is 2.1%. Another feature of a lot of the maps that we have here, so if I click on them, so I grew up in Pennsylvania, so I'll choose Pennsylvania as the example. If I click on Pennsylvania, let's see what happens. Takes a moment to open up. So this actually takes us to a new web page. And it's loading kind of slowly. It might be because I have so many other web pages open up right now. But it shows basically a table of a broad array of labor force measures just for Pennsylvania. So just another little added feature that we can do with interactivity. So moving on, let's show a few more maps. Some of these will be hopefully a little bit more fun, a little less stodgy. Okay, here's actually a map of percent changes in employment for metro areas. It's kind of a freckle map. All of the dots, the bubble size indicates the size of the change. So bigger dots mean bigger change. Red dots mean declines. So if we look at this great big red dot down here, that's Pine Bluff, Arkansas. Things aren't going so well right now in Pine Bluff. We see bigger dots in places like Idaho Falls, Idaho. One of the things that I've learned very quickly, I mentioned that people really care about geography and especially where they live and where they work. We tweeted this particular map a couple weeks ago, and one of our Twitter followers who was from Utah noticed that the first edition of this map, our bubbles were actually a little bit off out in Utah. We were just off, just really by about a millimeter, and it made it look as if all of the kind of the population centers in Utah, Ogden and Provo and Salt Lake, originally it looked like all those population centers were west of the Great Salt Lake. Now, I'm not from Utah, so I'm not as familiar with Utah geography, but this guy was, and it showed me, he pointed out, he says, hey, all your population centers in Utah should be east of the Great Salt Lake. So we quickly went and fixed the map code and moved it the millimeter or two over to the east where it should have been. But I thought that was pretty impressive that someone noticed that kind of detail in a map like this. Kind of makes me a little bit nervous that what other types of mistakes have we made that no one's found out about yet. But anyway, I kind of like this map. The freckly look is kind of funny, but I think it's very useful in helping people see again labor market conditions where they live and work. So here is a map at the county level. We'll blow this one up a little bit more too. So this one was a map we published We actually published it a little more than a year ago for President's Day 2015. So all of the colored counties you see, these are all the counties in the United States that shared the name of a U.S. president. That doesn't necessarily mean that they were actually named for the president. For example, there is a Reagan County in Texas. There is a Clinton County in New York. Those were not named for Presidents Reagan or Clinton. But nevertheless, they shared the name with them. Many of these counties, of course, Jefferson County and Washington County, and where I'm sitting right now in Washington, D.C., were, of course, named for U.S. presidents. Right here, I will hover over Madison County, Iowa. As we all know, there are some scenic bridges in Madison County, Iowa. But this is showing, what this map is showing is a wage comparison of all the different counties named for U.S. or sharing the name of U.S. presidents across the United States. Again, with the legend, we can highlight the counties in the particular wage categories. So, moving on. Now, here we get to the really cool stuff. Let me blow this up a little bit. So, if you like the interactivity that we have in our charts and maps, we can go one step further. The next few maps that we'll look at show animation, not just interactivity. And I'll show you what I mean by animation. So this is a map showing unemployment rates by state. We published this back in the spring of 2014, so it's almost 2 years old. But what we see here in the default view is the unemployment rate just as of April 2014. Interesting, not that exciting though. But let me hit this play button. So let me first explain. Whenever you see a dark state, like here, Nevada, the darker blue, higher unemployment rate. Lighter blue or white, these are lower unemployment rates. So let me hit the play button, and we're going to go back to January 2004. And we're going to watch kind of a time lapse of unemployment rates state by state over about a 10-year period. So 2004, 2005, into 2006, most places, pretty light colored map. And then something's going to happen in a moment here. This is looking kind of ominous. So, of course, this was the Great Recession, when darkness covered the land. I should narrate movies. So anyway, I think that's pretty cool. I hope you do too. I remember when we published this and we tweeted it. I remember seeing comments on Twitter, people saying things like mesmerizing. I mean, people were using words that I'm not used to hearing in the context of BLS data. Mesmerizing is not a term I ever remember hearing in the 25 years I've worked here. So that was very gratifying to see that. A few more like this. Here's another one I think is kind of interesting. This is showing major industries by state. So, starting off back in 1990, most of the U.S. was either a blue state, which is in this case manufacturing, or a red state, which meant that the largest industry in it was retail trade. One exception, of course, was this purple state, Nevada. They've got some other types of industrial base here. Let me hit play on this one and watch a transformation. So in a minute, there we have a new color, orange, for healthcare and social assistance. Watch what happens. So over time, over the period from 1990 to 2013, we see a transformation where much of the country, the the largest industry in each state was manufacturing. Today, in most states, healthcare and social assistance, except for Montana. I'm not sure, or sorry, Wyoming. Not sure what's why accommodation and food service is the largest industry in Wyoming. That kind of surprises me, but anyway, again, I think that's kind of a neat way to present data and show sort of an economic transformation in the country over time. Here's another one. One more example of animation. So this year, of course, is an election year. We all can't get away from it, it seems. This is, I think, kind of a fun map, an interesting map, showing employment in political organizations, political parties and political action committees and things like that. And it's showing percentage changes from the previous month. So darker green is larger growth. Darker red is larger declines. And so you'll very much see a cyclical pattern and a seasonal pattern that shows up in these data. Now, one slightly different thing, okay, let me try again. One variation of this map that we didn't have in the previous two is that we have this little slide bar up here. So we can manually move things across if we want to look at a particular time period. But let me go back to the beginning and hit play. And again, you can see the seasonal variation. So here we'll get into, in a moment, 1991, kind of employment declines in political organizations. But then we're getting into an election year, 1992 again, and you see a lot more green. And then right after the election, a lot more red again. Just, I think, an interesting depiction of the sort of the cyclical and seasonal variation in employment in this particular industry that, of course, ratchets up with the election cycle. And that might be the national election cycle, but of course each state has its own unique local election cycles as well. For example, I live in Virginia. In Virginia, we elect our legislature and our governors in odd-numbered years. So I think only 2 states, Virginia and New Jersey, do that. So you'll see a little bit different pattern in those 2 states than you see in other states around the country. All right, so I'm not going to let this run. We don't have to sit here and watch. I think you get the picture. But again, I think it's an interesting way to present a whole lot of data and really make it come to life for people. Now, last little map. I mentioned that we publish the Economics Daily, as I said. It's not all about just data and putting out important economic reports. Sometimes we like to have fun. So sometimes we'll celebrate holidays, not necessarily the major ones you might expect. This past fall, we decided we were going to have a little bit of a celebration for Oktoberfest. So we decided to do a little bit of have a little bit of fun with a measure that we call the location quotient, and I'll explain what that is in just a moment. The employment location quotient for breweries. Lots of breweries around the country. So what a location quotient is it's a comparison of a state or an industry's employment share in a particular state with the U.S. average. So, for example, if a state had the same share of employment in a particular industry as the U.S. as a whole, the location quotient would equal 1. If the state had a higher concentration of employment in that particular industry than the U.S. average, the location quotient will be greater than 1. So some of the states with these high location quotients for breweries, I'll light them up here. You can see. So if you want a good beer, a good micro beer, Colorado is one place to go. They've got a lot of breweries out there. Oregon is another one. The guy who made this map happens to be from Oregon, so I think he was very pleased to see that on the map. Montana, who knew that there was a lot of brewing going on in Montana? And of course, Missouri and Michigan. Or sorry, Wisconsin. I knew what state that was the moment the words came out of my mouth. I know I know we have at least one audience member who's from Michigan, so I don't mean to offend you by confusing it with Wisconsin. Um, moving along, Julie, can we go back again to the presentation for a little bit?
You got to go back to the webinar. I switched the slides for you, Jay.
Okay.
So you got to go back to the room for the
There we
Adobe
go.
Connect. Yep.
Okay.
And it's about
So,
2:47, just so you know.
okay, I will be wrapping up really shortly. Just like a couple things I want to show real quick. So, okay. So I have a few others that I included in the presentation. I'm not going to show them all here, but as I understand it, you all can actually get a hold of my presentation, so you're welcome to have fun with them on your own. I want to briefly talk about another publication we have, Spotlight on Statistics. This is the one where we're telling kind of a longer story through a series of slides in a slideshow format, or through a series of graphics, I should say, in a slideshow format. So if we can go back to a few more of those on the website really quick, I'll show you some cool things. So this is a spotlight on statistics we did in last fall, celebrating one of the surveys. Is actually one of the programs I used to work on here at BLS. It's called the National Longitudinal Surveys, and it's looking at a couple of different groups of people and tracking them over an extended period of their lives. So we have actually two groups that we're tracking right now. One is a kind of the younger portion of the baby boom generation. It's a group of people born in the years 1957 to 1964. And then part of the millennial generation, people born in 1980 to 84. So the way Spotlight on Statistics works is that we start with kind of a cover image, and then you can just kind of scroll to the right, and we can look at things like, I'll blow this up a little bit, we can look at things like the number of jobs that the young baby boomers held in their lifetimes, and the variations, in this case, by educational attainment. Let me scroll through here and show you some things that, here's one that I think many of you might be interested in. I know all of you, or most of you, are teachers. Many of you are teachers at community colleges. This is, I think, an interesting comparison of these two different generations. So the younger generation, the millennials, more likely to go to college, to attend a four-year college than were their older counterparts, their baby boomer counterparts. And the gap is especially large among women. It used to be that among the baby boomers, there were a slightly higher percentage of women than men who attended four-year colleges. For the millennials, the people born in 1980 to 84, the gap is much larger. A lot higher share of women at four-year colleges. Two-year colleges, also the same. It used to be that men and women went to attend community colleges in about equal proportions. For the more recent generation, these are people who are now in their 30s. You can see quite a bit of growth in attendance at community colleges. And again, as with the four-year colleges, a larger share of women. Let me quickly see if there's anything else. Some other things that we get from this survey, and again, you can kind of look at these on your own time. It's a very comprehensive set of surveys. We get information on employment, and as I like to describe it, all those things that affect or are affected by employment. So we collect lots of information on things like, the usual suspects like education, but also on things like marriage and divorce and fertility, and things that will affect and are affected by people's labor market decisions. Another spotlight that we published within the last year. So we published this last spring, and this looks at a broad set of measures of inequality, certainly a topic that's very much in the news over the last few years, looking at inequality not just in terms of compensation, pay, and benefits, but in terms of how people spend their time and how people spend their money, depending on where they fit in the income spectrum. So I think an interesting way of looking at it, we look at some different measures of, like for example, in this chart, we're looking at percentiles of earnings and not just those measures of central tendency, such as means or medians. Moving along, we're almost done here. This last spotlight I want to show you. So you may remember, if you're into statistics, that 2013 was the International Year of Statistics. And so we put together a spotlight on kind of an overview of some of the things that we do here at BLS. But there's a few charts in here that we included to try to illustrate some statistical concepts. And one of them is the idea of seasonality. Many of our data series, we do seasonal adjustments on them to try to smooth out the seasonal variation in order to discern kind of the underlying cyclical patterns. There are some people who insist that seasonal adjustment is some sort of nefarious manipulation of data. I assure you it is not. Whenever we report something that's seasonally adjusted, sometimes that means that the unadjusted number is higher than we report, and sometimes it means the unadjusted number is lower than we report. They tend to even out, and that's this graphic I think is a good illustration of that. So you can see we've actually kind of color coded it. So for winter, spring, summer, and fall, those are what those different colors on the graphic represent. This is not actually an interactive graphic; it's just a static image, but you can see the not seasonally adjusted, the large seasonal variations in retail trade employment. So these big spikes are before the holiday shopping season, and these big declines are right after the holiday shopping season. With seasonal adjustment, it kind of smooths those out so you can see the underlying trends. We can see a decline here as we go through the Great Recession, and then kind of a gradual upward slope as we get into the recovery period from the Great Recession. Another slide I want to show you in terms of statistical concept is the idea of confidence intervals. So every month we report on non-farm employment. This is widely watched by Wall Street and by all sorts of political pundits and others. And, we might report that employment grew, 200,000 over the month. But the consensus forecast was that it would grow 150,000 from all of the so-called experts. And they'll say, oh, well, employment was much stronger than we thought it was. Well, I think this graphic is a good illustration that maybe not. So this is showing the confidence bounds. It turns out that whenever we report a monthly change in non-farm employment, there's about a plus or minus 100,000 job margin of error there. And so this lighter blue field shows you that confidence interval. So going back to, for example, in 2012 and 2011, actually I guess 2012 and mid-2012, we had 1 month where the employment change was about 100,000. Well, that might have really been 200,000, or it might have really been nothing. So I think it's important to keep in mind that most every estimate that we publish has some sort of margin of error. All of them have errors in terms of non-sampling errors, in terms of misreporting and all sorts of things that can go wrong whenever you collect large amounts of data. But for our programs that are based on estimation, sampling, inferences from sampling, they all have a margin of sampling error too, and this is what this graphic represents. So I've got some other things that I can show you, but we're running out of time, and I don't want to keep you here. So I think I'm going to wrap it up. As I said, if you want to get my slideshow, Julie, I think we can go back back to the presentation. There we go. If you want to spend more time on any of these on your own, that's fine. Couple real quick things I want to explain. This thing I'm highlighting here, enhancing our news releases, is a blog post that we published recently, explaining some expansion of some graphics that we're adding to our major monthly and quarterly economic reports. This last thing, this K-12 chart maker tool, this is actually something we have on our kids pages that in a kind of a simplified form enables, we say kids, but not necessarily kids, it can be grown-ups too, you can stick your own data in there and make your own have fun making your own interactive graphics. But feel free to use my slideshow. If you have questions about it, feel free to email me. Here's my contact information. I guess now is the time to open up the floor for people to ask questions, and hopefully I'll have the answers for them.
You did have two questions that showed up in the chat window while you were talking. The first one came when you were showing that chart that you said was kind of long, like it didn't fit on the page. It was the states versus the unemployment rates. And I think the question was, why don't you just turn it the other way and have the states going horizontally instead of vertically, so that wouldn't be as long?
Yeah, that's a good question, one that we've pondered, and the problem is that then it gets too wide, and that's especially, I think, a problem for small mobile devices. We're kind of, there's no ideal way for a chart like that to present 50, actually really 51 if we count the District of Columbia states and the District of Columbia. We decided to go vertically instead of horizontally, but neither of them is ideal.
Right. And the second question was, what software is being used to produce these graphs, and how long does it take to build one of these?
So we use software. It's a JavaScript-based software called HighCharts. We bought HighCharts. BLS bought HighCharts about five years ago for about $500. I think it was the best $500 we ever spent. It's actually pretty easy to code graphics using HighCharts. It's pretty intuitive. It does help to know a bit about JavaScript, which is kind of a drawback. You have to send people to training. But I've got this guy on my staff who is a guru with JavaScript and with HighCharts, and he has created an application that we use. My staff uses literally every day, and once we work out a few bugs and things like that, we clean up some code, we're going to make it widely available for all 2,400 BLS employees. The application enables you to start with basically data in an Excel spreadsheet where you can paste it into a tool that makes an HTML table, and then press a button, and within about 5 minutes have a publication-ready set of interactive graphics or maps. And Allison asks, HighCharts, yes, that's the correct spelling, H-I-G-H. I think actually the way they do it is they mash high and charts all together as one word. And strangely, I think they capitalize the H and they capitalize the C in charts. But it's all marketing.
Yeah. So it is.
We've looked at other software tools such as Tableau. They're great tools. They really are. We've experimented with them a little bit. The problem we've had with Tableau is we haven't been able to make it compatible with our website. We have some, as you might imagine, some major security concerns in being able to keep data close to the vest before we publicly release them, especially some of the kind of market moving measures. And we're not able to do that with Tableau. We have some security concerns there. Plus also, Tableau is pretty pricey. With HighCharts, it's open source software, and it's much more cost effective for us, both in terms of not costing a lot of money, but also not costing a lot of time and training expense.
Okay. So thank you very much for today's webinar, Jay. If everyone could thank Jay, that would be awesome. I'm not done with you guys yet because you have to fill out the survey. So I'm going to switch off his slides. Someone asked how to get his slides, and that will be made available to you guys as well. I want to thank you for participating in today's webinar and supporting AMATIC. Make sure that you're a member. That would be awesome. We are on social media, so there is a Facebook page for AMATIC. And when you're looking for recordings of past webinars like this one, it's if you go to bit.ly, the bit.ly, and then AMATIC -webinars, you'll get all of them. It takes about 1 to 2 weeks to produce this and upload it and get that all taken care of. I will send an email to everyone once that is taken care of and it's up on the website so that you know you have an alert. If you would please take just 2 minutes to evaluate the webinar content and the presenter. It's bit.ly/AMATIC43, or you can just click on your screen. If you need the confirmation that you participated in this webinar, please make sure you fill out that optional section at the end of the evaluation. I think that's everything. I'm going to stop recording now.